So now that we've seen all of the individual translations, what happens when we have functions with more than one translation? Now, here we're going to establish some strategy for sequences of transformations. Because when we are working with functions that have more than one translation, we often have to apply these transformations in a specific order to guarantee that we arrive at the correct result. So the first translation that we want to keep in mind is that of horizontal shifts. So in terms of our horizontal translations, we want to make sure that we are beginning by working within the parentheses of our function to identify or even apply a shift of our parent function's graph to the left or to the right. The next step that we want to consider are vertical stretches and compressing. So in other words, we want to deal with any multiplication in step 2. Now, just like when we were looking at the definition of a vertical stretch or compression, we have to be mindful of negatives, which brings us to step 3, reflections. So when we're thinking about reflections, we are dealing with any negation or multiplication by negatives. And last but certainly not least, in step 4, we want to think about any vertical shifts. So in step 4, here we are looking outside of the parentheses of our function to identify any addition or subtraction of constants, which will shift the graph up or down. Now, let's put this sequence of transformations into action with the following example. So to practice our strategy for a sequence of transformations, let's write an equation for the function whose graph has the following characteristics. So we have the shape of the square root, but this graph is going to be reflected across the y-axis, shifted left 2 units, and shifted down 1 unit. So as always, let's start by identifying what the parent function is. And so we luck out here. We're actually given the parent function. We know that the shape of this new graph should mimic that of the square root. So we can say our parent function is y, or f of x, is equal to the square root of x. Now, with the remaining 3 translations, let's go ahead and keep the order of our sequence in mind. So now that we've reminded ourselves of the order in which we should apply these individual translations, let's start by looking for horizontal shifts. And we can see, looking up at our given characteristics, we do have a horizontal shift. The graph is going to be shifted to the left 2 units. So if we think about our parent function and the definition, we know that this is going to be f of x plus 2 to indicate a shift left, or the square root of x plus 2. Now the next step in our sequence is that of stretching and compressing. But looking up at our characteristics, we don't have any, so we can say this is not applicable. What about reflections? Again, looking up at our given question, we can see that yes, the graph is going to be reflected across the y-axis. Now be careful here. Thinking about our previous step, step 1, a reflection across the y-axis means that we need to multiply this entire argument by negative. So use your parentheses for safety. Or in other words, we can say that we have f of minus x plus 2. So you're multiplying the entire argument by the negative to indicate a reflection across the y-axis. So you have this big old square root of minus, parentheses, x plus 2. And last but certainly not least, are there any vertical shifts? And yes, our final characteristic is a vertical shift of this graph down 1 unit. So we will be subtracting a constant 1 from step 3. Or in other words, we have f of minus x plus 2 minus 1 for a beautiful final answer here of the square root of minus x plus 2 And on the outside of our square root, we subtract 1. So this is the function whose graph has these 3 given characteristics.